Know what time it is? It's time for more fun with HBase. And this time we're going to integrate it with Pig, so we can get an example of how to actually populate an HBase table with potentially big data. Our last example using a Python script to do it was kind of interesting, but if you think about it, not all that useful in a big data context. What if I had more data than I could have fit on my local machine? I couldn't just write a little Python script that reads the local file system and shoves it into HBase, now could I? But Pig can do that sort of a thing. Pig can actually suck in information on my HDFS cluster and then turn around and write that into an HBase table. So when you're dealing with big data, something like Pig can come into handy for that sort of an application. So how does that work exactly? Well, if you're going to be writing stuff from Pig into HBase, first you need to make sure your HBase table is created ahead of time. So we're going to go to the HBase shell to set that up before we get started. And we have to make sure that the data we're importing has unique key values as the first column. So remember, in Pig, you create these relations through each line of your script, and that each relation has a row that has a unique key value. And then we're going to make sure that relation has columns that map up with the columns that we actually want to store in the HBase table. Okay? And the syntax for doing this is pretty simple. There's just a using clause we have to stick onto our store clause that tells it exactly what class to use to write the information out, in this case to HBase. And again, the point here is that this can work at high scale. So HBase is transactional on rows, so we can actually have many mappers associated with a Pig job storing information into HBase all at once, and we don't have to worry about it stomping on each other or anything like that. So this is one way of importing a massive data set into HBase all at once. And there are other tools for doing this too. There's actually a script that comes with HBase called import TSV that does pretty much the same thing. So, if you do have your data in some sort of a delimited format just sitting on HDFS and you just want to shove it into HBase, there's also a tool called import TSV you might want to look into as well. A little bit simpler. So let's go do it and have some fun with Pig and HBase working together, hand in hand. All right, let's do it. Have some fun with Pig and HBase working together. So what we're going to do is actually import the users table from the Movie Lens dataset that contains information about each individual person that's rating movies in there. Things like their age and their occupation. So let's start by uploading that information into HDFS. So I already, again, still have my virtual host running in VirtualBox, and I still have the HBase service running on there. What I need to do is actually upload the data itself. So let's go to the Files view in Ambari. And I'm going to go to user MariaDev, which is the user account that I'm working underneath. And in the ml-100k folder, I'm going to upload the u.users folder file. So let's go ahead and hit upload. And I will navigate to where I save that, which for me is in my downloads folder. Let's sort by name so I can find it a little bit more easily. ml-100k u. Where are you? u.user, there it is. So we'll upload that up. And so now we have the u.user file sitting on HDFS on our little virtual machine. Let's take a look at what's inside of it. So you can see this particular file is pipe delimited, and it contains a user ID followed by an age, followed by a gender, followed by an occupation, and their zip code. So some interesting information about each user, and you could use this potentially to see if there's interesting patterns between movies that executives like versus writers or technicians or whatever, right? Or break it down by age or gender. Cool possibilities there. It's a fun data set. So we have this sitting in HDFS. Next thing we need to do is to actually import it through Pig and save it into HBase. So let's figure out how that works next. First thing we need to do is create our HBase table to receive this information. So I'm still logged in to the local server here. Let's type in HBase shell to get into the interactive shell for HBase. And I'm still logged in as root here, by the way. And once we're in here, we can do some fun things. Like, for example, we can type in list to get a list of all the existing tables on this HBase instance. You can see that Hortonworks has set up a few for us already to play with, but we're going to create a new one. And what we're going to do is say create, quote, users, comma, quote, user info. And this is saying create a new table called users that consists of the following column families. And we're just giving it one column family named user info in this case. All right, so I went ahead and did that. If we do another list command, we can see that our users table now exists, but there's nothing in it yet. So let's exit out of here. Exit, now that we've created the table that we need. And let's download a script to actually do what we want. So I've uploaded this for you at the following URL. You can type in wget http://media.sundog-soft.com/hadoop/hbase.pig. All right, and we can take a look at this just using the less command, less hbase.pig. And let's see what's going on here. So just 2 lines in this script, very simple. First thing we're going to do is create a relation named ratings, created by loading from HDFS the file user mariadev ml100k u.user, the file that we just uploaded into HDFS a few minutes ago, using pig storage of a pipe, saying that we want to use pipe as a delimiter in that data file. And we're going to store it as the following format. So this relation is going to split that up into an integer user ID, an integer age, a char array gender, really that could be a single character, a char array occupation, and an integer zip code. Okay, so now we have a relation where we've extracted the information we want in just the right order to map up with our HBase table that we just created. So that first column has to be our key. Okay, so the unique user ID is the first column that we extract into this ratings relation, followed by all the stuff that we want to put into the user info column family. So now let's do that. We'll say store the ratings relation into HBase users, so into the users HBase table, using this class name, which tells it to actually use this piece of code to transmit the data into HBase. So org.apache.pig.backend.hadoop.hbase.hbase storage. And then we will give it the actual mapping to HBase columns. So the key is implicit. So the very first column will always be extracted and used as the row key value. But then we're going to say we're going to take the second value, that age integer, and we're going to map that to the user info :age column. So remember in HBase, columns are identified by their column family column name. So user info :age, followed by user info :gender, user info :occupation, user info :zip. So we're not really doing any sparse data here, but we are using the concept of column families just to logically group together this information about each user. Okay. So now that we have a feel of what's going on there, let's go ahead and run it and see if it works. So I can just type in pig, hbase.pig, and off it should go. So far, so good. So remember, pig is doing some pretty crazy stuff. It's actually going to be kicking off a big old MapReduce job to run this and distribute the work if it needs to. Although that's admittedly overkill for data as small as this, but let's just pretend this is big data, shall we? But the point is, these very same commands would work equally well on a giant cluster with a massive data set. So the beauty of Hadoop is that you don't have to think about all that nonsense. It worries about it for you. All right, it's done. Success. So let's take a look within HBase and see if it's really there. Let's go back to the HBase shell. HBase shell. So let's do a list just to make sure our users table still exists. It does, and we can use the scan command to take a peek at what's in it. So we can say scan single quote users single quote, and there we have some data. Very cool. Haha. Okay, so you can see, for example, let's take a look at user ID 99 as an example. So you can see 99 actually contained these 4 unique columns. So the output here is giving you the row ID, user ID 99, the column name, which is the aggregate of the column family and column name. So user info age contains value 20 for user 99. So user 99 is 20 years old. And note the timestamp was automatically appended as well. So remember, each cell in HBase has versioning built in. So I can actually retain different copies of this data over time, and that timestamp is automatically appended to let me know when that was inserted. There are ways in HBase of overriding what gets written in there, so if you want to have more manual control over those timestamps, you can do that, but by default it just does it based on the system time. We can see user 99 is also a male gender, is a student as an occupation, and lives in zip code 63129. So there you have it. It actually worked. If you want to clean up your mess, we can do it like this. Before you can actually drop a table in HBase, you have to disable it first. So I'll just say disable users in single quotes. So that table is now disabled, and now I can drop it to clean it up and get rid of it for good. Bye-bye users, and if I do a list, users should be gone, okay? So at this point, I can exit out of the shell here, and I'm actually done with the console itself. I can exit out of that as well. We're out of the root account now, and finally we're out entirely. Also, to clean up, I should probably shut down the HBase service itself. So let's go back to the Services tab and go to HBase and tell it to actually stop, because we are done with HBase for now. Let that finish up. So there you have it, HBase in action. Cool stuff. So there you have HBase. Hey, if it's good enough for Google, it's probably good enough for you, right? If you need to vend massive amounts of data very quickly at massive scale, it's a pretty good choice, especially if that data is sitting on a Hadoop cluster already. But it's not always the best choice. Sometimes your use case might dictate a different solution. So let's talk about some other NoSQL or non-relational database technologies that you also might choose to integrate with your Hadoop cluster.